Okay, welcome to educator.com. In today's lesson, we're going to discuss solving systems of equations through multiplication. The underlying principle is that multiplying an equation by a constant also yields an equation. And we can use this principle combined with addition and subtraction in order to solve systems of equations. So the multiplication method is actually the first step. After that, in order to eliminate a variable and solve the equation, you're actually going to have to add or subtract as well. But starting now, just discussing multiplication. Previously, we saw examples such as this system of equations. 3x minus 2y equals 12. 4x plus 2y equals 16. And when we added these, the y dropped out. And then we could solve. And this was using addition. We could also use subtraction. What we're going to see today are situations where it's not quite so neat and easy. I'm not going to already have x's or y's that have the same or opposite coefficients. What I might see is a situation like this. 2x minus 3y equals 6. 4x plus 6y equals 3. Okay, when I look at this, I see that I can't simply add or subtract. If I do that, nothing's going to drop out. What I can do, however, is use multiplication in order to change one or both equations so that I end up with variables with opposite coefficients. For example, I can take the top equation and multiply by 2. So if I take this top equation and I multiply it out by 2, what I'm going to end up with is 4x minus 6y equals 12. With that, I take the second equation, 4x plus 6y equals 3, and then when I add them, the y's will drop out, and I'll get 8x equals 15. So I'm not going to solve this all the way out. Right now I'm just showing you the principle that in order to use addition or subtraction, sometimes you need to first multiply by one or both equations. Okay, in this first system we have 3x plus 6y equals 15 and 5x plus 2y equals 9. And I'm looking at these and seeing that I don't have anything that's going to easily, that it will drop out if I add or subtract. What I do see is that I can multiply in order to get a situation where I have variables that will drop out if I add or subtract. And I'm going to pick the simpler equation, 5x plus 2y equals 9. And I see that if I multiply that by 3, I'm going to end up with 6y, and then I can use subtraction. So first, I'm going to multiply the second equation by 3. That's going to be my first step. So I have the second equation, 5x plus 2y equals 9. Multiplying that entire equation by 3 gives me 3 times 5x plus 2y equals 9, or 15x plus 6y equals 27. And then I'm going to subtract one equation from the other. So now I have my second equation in this form, and I'm going to go ahead and subtract. So first I multiplied, now I'm going to subtract. So I have 3x plus 6y equals 15, and I'm going to subtract 15x plus 6y equals 27, and I'm going to be very careful with the signs. 3x minus 15x is negative 12x. Then I see that 6y minus 6x, my y's drop out. 15 minus 27 gives me negative 12. I go ahead and solve for x by dividing both sides by negative 12. and I get that x equals 1. Once I'm here, it's just a matter of substituting for x in either equation. And I'm going to go ahead and solve for the other variable as my third step. 3x plus 6y equals 15. If x equals 1, then 3 times 1 plus 6y equals 15. 3 plus 6y equals 15. 6y equals 12. Y equals 2. Okay, so my solution for x is x equals 1, and for y, y equals 2. I looked at this and saw that I did not have any variables with the same coefficient. Therefore, I had to multiply in order to get a situation where I had the same or opposite coefficients. And I looked and saw that if I multiplied this whole equation by 3, I would get a 6y. So I did that right here, and I got 15x plus 6y equals 27. That was my first step. My second step was to subtract. So I took my first equation and 15x plus 6y equals 27, and I subtracted, being very careful with my signs, so that I got negative 12x equals negative 12, or x equals 1. Then I substituted 1 into this first equation and solved for y, and y equals 2. In this second system, we have 3x minus 5y equals 2, and negative 9x plus 6y equals negative 24. I'm looking through here, and I don't have a situation where I can simply add or subtract the two equations to solve them. So I need to use multiplication. Looking at this, the simplest approach would be to multiply the first equation by 3. So I'm going to multiply (3x minus 5y equals 2). I'm going to go ahead and take that entire thing and multiply it by 3, which will yield 9x minus 15y equals 6. So I'm multiplying the first equation by 3, and now I have 9x and negative 9x. Then I'm going to add the two equations. So I took this first equation and turned it into this. So I'm going to write 9x minus 15y equals 6. For my second equation, I have negative 9x plus 6y equals negative 24. And I'm adding the two equations. When I do that, my x's drop out. And then I simply add negative 15y plus 6y, and that's going to give me negative 9y equals 6 minus 24 is negative 18. When I divide both sides by negative 9, I'm going to get y equals 2. Now that I'm down to this step, it's the usual solve for the other variable. Okay, so I have y equals 2. I'm going to go ahead and substitute that into the first equation. 3x minus 5y equals 2, or 3x minus 5 times 2 equals 2. 3x minus 10 equals 2. 3x equals 12, which gives me x equals 4. Okay, so what I ended up with is that x equals 4 and y equals 2 for this system of equations. I looked at this and saw that by multiplying the first equation by 3, I could get 9x, which means that when I added it to the second equation, the x's would drop out. So my first step was to multiply the first equation by 3 to give me 9x minus 15y equals 6. Then I took that equation, added it to the second equation. When I did that, my x's dropped out, and then I was easily able to solve for y. I took this value for y equals 2, and substituted it into one of the equations, right here, and that gave me x equals 4. So this was solving a system of equations by first using multiplication and then using addition. Solve the system 3x minus 2y equals 5, 4x plus 5y equals 22. This is more complicated because I look at it and I can't just add or subtract to solve it. And I'm actually going to need to multiply both equations by a constant, by different constants, in order to get a setup where I can add or subtract and have a variable drop out. When I look at this, I see that if I multiply the top by 4, I'll get a 12x. And if I multiply the bottom by 3, I'll get a 12x. So I'm going to multiply the top equation by 4, and then I'm going to multiply the bottom equation, or the second equation, by 3. Okay, so starting over here with the first equation. I'm going to go ahead and multiply that by 3, and that's going to give me, by 4. I'm multiplying the top equation by 4, so that's going to give me 12x minus 8y equals 20. Okay, so that's my top equation. My bottom equation, my second equation, I'm going to multiply by 3. So that's going to be 4x plus 5y equals 22. Multiplying that out, I'm going to get 12x plus 15y equals 66. Now when I look at these two equations, I see that if I subtract one from the other, the x's will drop out. So I'm going to go over here. Here's my first equation, 12x minus 8y equals 20. And my second equation, 12x plus 15y equals 66. And what I need to do is subtract. So for this first term, 12x minus 12x, it's going to drop out. Minus 8y minus 15y is going to give me negative 23y. 20 minus 66 will give me negative 46. I'm going to divide both sides by negative 23 to get y equals 2. Once I have y equals 2, I'm going to go ahead and substitute it in. I'm going to choose that original equation because it's easier to work with, smaller numbers. And I'm going to substitute 2 in for y. So I'm going to get 3x minus 4 equals 5, or 3x equals 9, or x equals 3. So the solution for these equations is that for this system of equations, is that x equals 3 and y equals 2. This is the most complicated one we've done so far because in order to get this set up so that I could add or subtract and eliminate a variable, I had to multiply the top by 4 and the bottom equation by 3. So the top equation I multiplied by 4 and the bottom by 3 to get these two equations. Looking at those, I see that I can subtract one from the other and the x variable will drop out. Solving for y equals 2, and then substituting that y into one of the original equations to yield x equals 3. When I look at this system, I immediately see that I have fractions. And when you're working with systems of equations that involved fractions, the first thing you want to do is eliminate the fractions because they're a mess to work with. So just get rid of them. Now, the way I'm going to do that is I'm going to take this first equation and I'm going to multiply by 3. When I do that, what I'll end up with is 3x minus 2y equals 3. Okay, so that's what I have for the first. For the second, I have 2x plus 1/2 y equals 13. I want to get rid of that 1/2, so I'm going to multiply by 2. And that's going to give me 4x plus y equals 26. Now I've got something I can work with a lot more easily. I see I have 3x minus 2y equals 3 and 4x plus y equals 26. Well, all I have to do is multiply the bottom equation by 2. So first, get rid of the fractions. And I did that by multiplying the top equation by 3 and the bottom by 2 so that this denominator would cancel out. Then I needed to multiply the second equation by 2. So I'm going to go ahead and take the second equation, 4x plus y equals 26, and I'm going to multiply that by 2. That's going to give me 8x plus 2y equals 52. So I multiplied the second equation by 2 so that I ended up with y's that have opposite coefficients. Then I'm going to add the 2 equations. So let's go over here and look at my first equation, 3x minus 2y equals 3. And now I'm going to use this form of the second equation, 8x plus 2y equals 52. And I said I was going to add those. So when I add those, I get 11x, y's drop out, equals 55. Therefore, x equals 5. Now I'm going to substitute into either equations, but I don't want to mess with the fractions, so I'm not going back here. I'm going to use one of these equations. So if x equals 5, I'll go ahead and take this equation, 3x minus 2y equals 3. So that gives me 3 times 5 minus 2y equals 3, or 15 minus 2y equals 3, or negative 2y equals 12. Therefore, actually negative 12. Negative 2y equals negative 12, therefore y equals 6. Okay, so my final answers are that x equals 5 and y equals 6. I had to first get rid of the fractions so that I could work with something cleaner and easier to deal with. So I did that by multiplying the top equation by 3 and the bottom by 2. Once I had equations in these forms, all I had to do was multiply this second equation by 2 to give me 8x plus 2y equals 52. Once I had that, I added these two together. My y dropped out, x equals 5. If x equals 5, by substitution, I see that y equals 6. So today we learned a method, multiplication, in which we had to manipulate the equations before adding or subtracting in order to solve for systems of equations. Thanks for visiting educator.com. See you soon.